Look at this question. A 5-watt source emits monochromatic light of wavelength 5000 angstrom. When placed 0.5 meter away, it liberates photoelectrons from the photosensitive metallic surface. Okay, when the source is moved to a distance 1 meter, the number of photoelectrons emitted will be reduced by what factor? That is the question. Can you tell me the reason? I will explain the reason. Listen, it's an indirect question. It's an indirect question. Look here. There is a source. Okay, there is a source here. Source means which emit photon. Okay, clear? Source is nothing but okay. Suppose here I am keeping plate, and later I change the position of the plate. Clear? I can change the position of the plate, or source can be position of the source can be changed. The distance, if you change the distance between the source and the plate, if you change it, what happens that the number of photons reaching the plate will be changing. Understood? Clear?
Uh,
You understood the reason. Okay, the number of photons, I am not talking about energy of the photon, number of photon reaching the plate will be changed if you change the if you increase the speed distance between the source and plate. Understood? Clear?
okay, sir.
So what happens is, you understood, you please understand one formula, that number of photons, it's a very simple thing, you better memorize that. Number of photons reaching the plate directly proportional to is yes, 1 by d square. You better memorize this. Okay, clear? D is the distance between the source and a plate. Clear? Understood?
Yes,
I
sir.
told you that if you increase d, what happens? If you increase d, the number of photons reaching the plate will be reduced. Clear? Clear? The intensity will be reduced. You agree with me?
Okay,
Clear?
sir.
Intensity will be reduced. Can you tell me the logic behind it? Can you tell me the logic? What is the logic behind it? Why the photons, number of photons reducing? Listen, initially I keep the plate here. Okay, I keep the plate like this. What happens is the photons reaching like this. Understood? The photons are entering the plate like this. Understood? A certain number of
Yes, sir.
photons will be reaching the plate. If you change the position, what happens is, if you change the position, what happens is, the a few photons will be I mean cannot enter the plate. Understood? If you change the position, some for the photon will be moving like this. A few photons will not be able to reach the plate. Clear? Goes like this, moving in a straight line. You know that. Okay, clear?
Uh,
So only a few number of photons will be entering in the new position. Understood? Clear?
mm,
So you understood the logic behind it. So as the
yes.
distance increases, the number of photon reaching the plate will be reduced. So the please memorize this result. Number of photon reaching the plate directly proportional to 1 by d square. Please note it. D is the distance between the source and uh, plate. Okay,
Plate.
clear.
Mm.
So so in the now you can understand that. Okay, or equal to k in k by d square, you can write like that. Intensity, number of photon is also said to be the intensity. Okay, clear?
Okay, sir.
Or power, you can say like that, power. Okay, power,
Mm,
intensity, all these are depends on the number of photon. Okay, clear?
mm,
So a 5-watt source emits monochromatic light of wavelength. Uh, when placed 0.5 meter, it liberates photoelectrons from the photoelectric. Okay, okay. We don't need 5 watt, 5000 angstrom, etc. Clear? Understood?
mm.
here what happens is initially the number of yes, number of photoelectrons, let me denote by some letter, say n1. In the first case n1 equal to, if you remove the proportionality constant, you have to use some number, say k. In the first case, number of photon n1 is equal to k into 1 by d square. In the first case, d was 0.5. Clear? Understood?
Mm.
K. You know that if the proportionality is removed, you have to put some constant k. Correct?
Then,
So the number of photons entering the surface n1 equal to initially k times 1 by 0.5 square. Understood? Clear?
yes, sir.
And in the second case, what happens? n2 equal to the same constant k into 1 by 1 square. Clear? Okay?
Mm-hmm.
So we have to find the ratio actually. Taking the ratio both sides. Clear? Understood?
Mm.
n1 by n2, the k will be cancelled. 1 by 1 by 2, you will get 4. Okay? Shall I explain that step? You can do
No,
it later.
sir,
Okay.
I understood.
So yes, so
1 by 1 is be on top.
the number of photons liberated will be reduced. Yeah, yes, will reduce will by the factor 4. Clear? Understood?
Yes.
Then the second case, okay, you understood. First case, n1 equal to 4 n2. So n2 is equal to n1 by 4. n2 equal to n1 by 4 means that the number of photons is reduced by a factor 4. Clear?
Uh,
So the concept is clear to you?
okay, sir.
So you please read the entire solution. If you have any doubt, please ask. Okay?